Welcome to the Ira A. Fulton Schools of Engineering at Arizona State University. Our college houses the undergraduate and graduate degree programs for engineering, computer science, and a majority of the technology programs that are offered at ASU. This presentation will explore the Aerospace Engineering degree program with a concentration in autonomous vehicle systems. ASU has 4 campuses that span the Phoenix metro area, and the Fulton Schools of Engineering are located on 2 of those, the Tempe campus and the Polytechnic campus. The degree programs within the School for Engineering of Matter, Transport, and Energy, also known as SEMTE, are located at the Tempe campus, but all campuses are open to all students regardless of where their program is located. We offer a free inter-campus shuttle for our students so that they can explore courses, student orgs, activities, and resources at any campus. At Fulton, we offer 25 undergraduate degree programs, which provides a lot of choice and flexibility in finding the program that fits for you. We are called the Fulton Schools of Engineering because we categorize our degree programs into 6 schools, which are organized by theme and location. The first 5 schools from left to right are housed at the Tempe campus, and the Polytechnic School is housed at the Polytechnic campus. Our aerospace engineering students belong to the School for Engineering of Matter, Transport, and Energy, which you will see towards the right of the infographic. Each school has its own director, affiliated faculty, and advising unit, so as to provide greater support and specific guidance to the students within that school. ASU and Fulton have direct admission, meaning when students apply, they apply directly to the degree program they want to pursue. As long as a student meets the admissions criteria for their program of interest, they are admitted. It is important to note that some of our degree programs, including aerospace engineering, have slightly higher admissions criteria than the general university requirements. For a comprehensive list of admissions criteria, you can visit the Fulton Schools of Engineering website at engineering.asu.edu. Students in SEMTE are located at the Tempe campus, which is both their academic and residential home. First-year freshmen are expected to live on campus their first year, and our SEMTE students are currently registering for housing in the Tucker House. Tucker House is the residential hall for all of the engineering disciplines, and we are also expanding to the University House for the 2020-2021 academic year. Students that are a part of Barrett the Honors College live in Barrett housing, but are given the opportunity to live on an engineering-specific floor if they choose.
Emerging emphasis on autonomous aircraft technology and operation in both military and civilian sectors signals a new era within the aeronautical community focused on autonomous vehicles and systems. The concentration in autonomous vehicle systems provides students with general exposure to engineering of autonomous aircraft and greater depth in one area of specific importance to unmanned aerial vehicles. The curriculum is structured so students have general exposure to the engineering of autonomous aircraft plus track courses in one area important to this field. Tracks are guidance, navigation and control, and communication. The Aerospace Engineering program consists of 120 credit hours. The multidisciplinary general education classes required in the major complement the specialized courses of the major by teaching fundamental skills. A well-rounded education gives students the tools to think creatively, adapt quickly, and work effectively with others, which are skills needed in any field. The first year in aerospace engineering consists of English composition, math, chemistry, and physics. Engineering-specific classes begin in the second year, and aerospace engineering classes begin in the third year. Also, some classes in the third year are only offered once a year, thus it is important to stay on track and take each course in appropriate semester. An accelerated program is available for students pursuing aerospace engineering with a concentration in ABS, also known as 4+1. Combining graduate and undergraduate coursework in accelerated programs saves students time and money. The research is rigorous and the work is focused, but students get an enriched educational experience that will prepare them for doctoral studies or industrial position by earning a BSc and MS in 5 years. Requirements include 3.5 GPA in all courses towards the degree, have earned or in the process of earning 90 credit hours, and 9 credits can be shared between undergraduate and graduate program. Students pursuing aerospace engineering ABS concentration can choose to pursue 4+1 in aerospace engineering, mechanical engineering, or robotics and autonomous systems. Students who earn a degree in this concentration are prepared for a career in the aerospace industry, focusing on unmanned vehicles. Most graduates are employed in this aerospace industry or in the government position related to aerospace. Specific careers in aerospace engineering include aeronautical and space systems integration, configuration development, material and structural design, propulsion engineering, space mission design and analysis, vehicle and component analysis using computer-aided tools, vehicle design and performance, and wind tunnel and flight testing.
Hey everyone, my name is Philip Mulford. I'm currently a 4+1 student at ASU with pursuing a master's in robotics and autonomous systems, but my undergrad degree was in aerospace engineering with a focus in astronautics. That being said, I was briefly a autonomous vehicular systems concentration, and between my undergrad degree and my master's degree, I do have some commonality there. I came all the way from Warrenton, Virginia. It's about a 2,600-mile journey from by plane. It's a fun time. And I've been at ASU for the last 5-ish years. I've had a great time here. I've had a ton of opportunities, really opportunities that I would not have had going anywhere else. I was able to do a full year of research that I got paid to do. Professor got paid to do. I got paid for equipment, things like that. I've been involved on the leadership of multiple organizations for Fulton ambassadors, which is doing these slide decks right now. For Tempe, which is the Engineering Honor Society. I had the opportunity to do the Grand Challenge Scholars Program, which is a program that you take a couple extra courses that really allow you to focus on the why of why you're engineering rather than just the what. So, we don't turn into Jeff Goldblum, Jurassic Park, where we spent so much time figuring out if we could do it, we didn't figure out whether we should. That's kind of the goal of that. And then I got to do some other stuff too. I played club Quidditch. I led a team to nationals. And yes, Quidditch is a real sport. But really, I mean, I talk about all these things because it illustrates the whole gamut of opportunities that ASU has provided me with. And that's just, the organizations I was able to be part of at the school. I was able to enrich my my purely academic pursuits. I was able to enrich my public speaking, my leadership skills or abilities. I was able to and just everything in between. I even did Model UN for a bit, although I ran out of time for that one. And that's just talking about stuff I did within the school. I had a couple internships. I interned at what was UTC Aerospace Systems. Now it's Collins Aerospace, soon to be Raytheon Technologies Company, I believe, where I worked as a software engineering intern for the summer. You may notice that has nothing to do with my degree. I mean, it does a little because everyone does software, but I was able to spin that into a guidance, navigation, and control internship at Northrop the following year. And I was going to be at MIT Lincoln Labs this 2020, but the pandemic canceled that. And all of that, so I've been allowed to, it's allowed me to really pursue my interests, the degrees and the opportunities I had here. And I'm even starting my PhD in Dartmouth in the fall. So, and I don't think I would have gotten in there without the tremendous opportunities and connections I was able to make here at ASU. ASU, and you talk about internships, ASU provides this amazing resource called the Fulton Career Center for students to go and make sure that they're going to get an internship, because we have 2 massive career fairs in the fall and spring where we fill out the Memorial Union, the Student Union. We fill up the entire second floor, and they actually have to turn companies away. It's so big. And ASU provides you all with these opportunities to be really prepared to present your best self to the recruiters, to make sure you get those interviews, to make sure you get those opportunities. Moving on to other program though. So I'm here specifically talking about the autonomous vehicular systems concentration. And while I ended up doing astronautics because it allowed me to work more on the space autonomy side of things that I was more interested in, AVS is this really cool program that very specifically focuses in on kind of the drone work in atmospheric drone work that is exploding right now. And actually, I think one of the coolest things about this course concentration is in your senior year, you actually have to take an ethics course. And I talked about the GCSP program, the Grand Challenge Scholars Program, about how that kind of provided me with the context to further understand what I'm doing. And AVS kind of requires the same thing with this ethics course, this political science course, because if you heard in the news, a good portion of UAV, autonomous vehicular systems work, has a very weighty ethical, political component to it. do we use drones? Where should we use drones? What's the legality of it? And that is incredibly important for any budding engineer to understand as they look to go into the workforce or advance their degrees, their academic career further with grad school. And then their capstone is also really cool, where they get to go and they build a drone that's I don't know, it's 6 feet wingspan. Oh, probably a little less, probably 4 foot wingspan, maybe a little more. Then they go and they develop an autonomy to go with it. So I know last year their goal was to deliver a payload to a certain site to simulate search and rescue supply delivery. And they work on that the entire year. They're actually one of, unlike the other two aerospace capstones, they do get some funding, or at least they did that one year, so they can build stuff in real life. So that's a really cool opportunity that AVS gets. So thank you very much, and best of luck with your college search process. Please feel free to reach out to me or any other Fulton ambassador if you have any more questions, or any other staff member if you have any other questions about ASU or the different degree programs provided.
Thank you for taking this time to explore the Ira A. Fulton Schools of Engineering. If you have any questions about applying to Fulton, please contact us at fultonschools@asu.edu. If you have any specific questions about the degree program covered in this presentation, please contact us at sempty@asu.edu.